My name is Theodore Vorillas. I'm currently working as a software engineer in an applicant tracking system called Workable. And I'm coming all over in Moscow from Athens, Greece. Today I'm super excited because I have the chance to present you one of the most interesting, actually the most interesting project that I have ever had the chance to work with. So today I'm going to guide you step by step through the process of creating real-life accessible objects. So basically this is more or less a talk about accessibility in real life using the very basic principles of Internet of Things and JavaScript. Before we start though, it's really important to take a step back and take a look how the community has evolved over the past few years. You see, we are kind of blessed because for the past few years we have so many great people among us, constantly blogging, creating tools, and raising awareness about accessibility. So we have convinced our employers and ourselves that accessibility really matters and it's not a buzzword anymore. But what accessibility is all about? So if we take a look at the dictionary term of accessibility, we'll find out that accessibility refers to all these actions we have to take in order to create products, systems, or environments accessible to everyone. As far as we're concerned, though, the term itself is a bit vague. It has applications in different scientific fields, from construction to engineering, computer science, and so on. As far as we're concerned, though, as web developers, software engineers, web designers, we are mostly focused into creating accessible communication systems. So we are using HTML or JavaScript in order to create web interfaces. We are integrating external software or hardware in order to communicate with our users. You will be fairly surprised, though, if I tell you that the very first accessible communication system was introduced nearly 200 years ago. This is Louis Braille. Braille was born and raised in a small city outside of Paris in the early 19th century. As a child, he suffered a terrible accident that left him completely blind from both his eyes. But still, he has mastered his disability, he has excelled his education, and at the age of 15, he got accepted in the National Institution for Blind Youth in Paris. It was there where he found out that the reading and writing system used by visually impaired people back in the days was a bit absurd. So people were using brushes, creating embossed letters with fat brushstrokes. So Braille committed himself into the cause of creating a system that could actually bridge the communication gap between the sighted and the blind. And at the age of 15, he introduced the Braille system. Braille is a tactile system. It's also the very first binary communication system ever made. So readers and writers are encoding letters, symbols, or numbers using combinations of raised dots and spaces. Its character allocates 6 positions, and its Braille character is also known as a Braille cell. Readers can trace down the letters using their fingertips, so they can recognize the letters, creating sentences, words, and so on. Braille system was good. It was actually so good that it hasn't literally changed since its birth. As we speak, there are Braille applications in different fields like music composition or math, and Braille system is also translated in more than 200 languages. If you're wondering how Braille looks like, just you can see Braille letters typed into packaging of products or in the buttons of elevators. So soon after, publishers using inkless typesets and heavyweight paper started publishing out Braille books. Also, in the early 20th century, typewriters were invented. So Braille typewriters allowed users to read or write Braille using a semi-automatic way. By the way, the happy typing lady you can see in the video, that's Helen Keller. Helen Keller was a famous American author, an activist about human rights, and also the very first blind, deaf person that has managed to graduate college. Our last piece in our puzzle was introduced in the late 1990s. That retro-looking machine is called a refreshable Braille display. So a refreshable Braille display has, as you can see in the bottom, it has a set of Braille cells, and it can get paired with external devices or software. So we can get this device paired with a computer or a mobile phone, and the readers using the navigation bar on the left, they can actually read with a more automatic way. So let's recap. The year is 2018. We have a system that actually works for like 200 years. We have the assets, we have the tools, we have the mindset. And as we speak, organizations, individuals all around the globe are raising concerns, are raising awareness about literacy rates and accessibility. So someone would say that we are in a really good shape, right? Well, actually, wrong. You see, numbers and statistics are like heartbreaking. As we speak, there are like 253 million people living with vision impairment around the globe. Most of them are suffering poverty or living within war zones. As a matter of fact, vision impairment it's somehow connected with common diseases like diabetes or cataracts or common eye infections. According to the United States healthcare organization, just 8.5% of visually impaired people in the States are capable of reading and writing in Braille. Global statistics are not available, but organizations are estimating that just 1% of visually impaired people around the globe are capable of reading and write in Braille. Just to give you a perspective about how low this number is, I'm gonna compare these numbers against the literacy rate in Ethiopia, one of the poorest countries in Africa. So in Ethiopia, 1 out of 2 people is capable of reading and writing. The most important factor about this slide is the fact that, as we speak, literacy rates are increasing all around the globe, but still, Braille literacy rates are stuck since the 70s. So we have to wonder ourselves, what's really the problem with Braille readers? So, as a matter of fact, in most cases, we're suffering from limitations of assets. If you think about it, reading or writing Braille, it requires just exercise with the actual text. So books are like super expensive. Their cost like 5 to 8 times higher than a normal book. And just only 1% of books are also available in Braille. Braille displays are like super expensive. They're starting from $500 to $8,000 each, depending on the size, on the length of the available cells. There are just a few companies that are producing Braille displays. There's no such thing as research and development, and the marketplace is extremely niche. Also, typewriters are super expensive as well. Although typewriters as a technology are a bit obsolete, people are still using them because it's an affordable way of using Braille. Okay. Now, let's assume that someone hands you this problem and tells you that, is there anything we can actually do as a community, as web developers, as engineers? Is there anything that we can do in order to help these people? Okay, now let's imagine that we want to build a device that will actually try to mimic how refreshable Braille displays operate. Before we start though, it's really important to set up some goals. First things first, when I have actually started prototyping this device, I had no idea about hardware or embedded development or so on. So we want to make this device as easy to build as possible, and also we want to make it hackable and expandable as well. Obviously, our device has to be accessible to everyone. So no sophisticated software involved, no sophisticated parts or exotic components or so on. Everything you're gonna see in this presentation was purchased from eBay, Amazon, and so on. And last, but certainly not least, we want to make this device as cheap as possible. Yeah, okay, lovely. But how? How is it even possible to start prototyping devices these days? Actually, is it even possible to prototype hardware these days? Yeah, apparently yes. We have a piece of technology called microcontrollers. So microcontrollers are tiny computational units, really easy to hack around and used for embedded development. Arduinos, Raspberry Pis, Photon, Espruinos, just to name a few. For the purpose of this prototype, I have decided to stick with one of the most popular one, the famous Arduino Uno. And I have purchased mine from eBay for like just a couple of bucks. And this is how Arduino Uno looks like. As you can see, the board itself has a set of general input and output pins popping out from the device. So we can expand our board just by attaching external modules like buttons, displays, and so on. As I want to start prototyping fast, I have decided to start simple, just by trying to blink this LED light. So I have attached this LED light on the port labeled 13th and the ground. Okay, lovely. But how can we actually start coding in Arduino? Different boards have different sets of language that you can actually use. So Arduino uses C++, and a sample piece of code that actually blinks the LED looks like this. So at the very top, we're allocating the pin labeled 13th, the pin that we actually attached to the LED. Afterwards, we're gonna set up the board, and we're gonna start controlling the pin. And finally, we're gonna set an infinite loop that will start blinking the LED with a delay of 500 milliseconds. Lovely, right? Yeah, but just to be honest, I was struggling as I was trying more advanced examples and trying different modules. I was struggling with C++, so just to be honest, I haven't had written C++ since my college years, like a decade ago. But I was super lucky enough, and I stumbled upon a project called Johnny 5. So Johnny 5 is a project brought to you by a Canadian company called Bokup, and it actually allows us to write native JavaScript, compile it, and target different microcontrollers. It's also a platform and an IDE. So we were gonna try and rewrite the example just by using the Johnny 5 module. At the very top, we're requiring the module. Afterwards, we're gonna set up the board, and when the board is ready, we will allocate the output pin, and using the Johnny 5 LED class, we're gonna start blinking the LED. And I can really feel some of you whispering, JavaScript, but what's the matter with you? What's wrong with you? Why are you trying JavaScript for embedded development? Just to be honest, JavaScript, in most cases, if you want to try different examples with Internet of Things, you will have to handle events. Like you're gonna find yourself into the situation of trying to interact with buttons or displays or sensors and so on. And JavaScript feels way too natural for handling events. Using promises or callbacks, JavaScript actually is an event-driven programming language. Also, you can accelerate your development using the whole Node.js ecosystem. Everything that's in the registry, you can take it and use it for embedded development. Like you can combine Arduinos with web servers, sockets, the Bluetooth API, everything you want. Also, portability. Even within the same brand, hardware specifications between boards are way different. So the Arduino Uno is totally different from the Arduino Mega, from Raspberry Pi, and so on. So using Johnny 5, you can reuse the same code targeting different devices. And that's extremely important for us. And last but not least, we have to admit that it's in our mindset. It's in the community's DNA. So people are trying to run JavaScript everywhere, from web servers, from mobile devices, NES consoles. We're embracing hacking, and that's really healthy for our community, for the people inside us. OK, so next up, we have to start thinking about designing. This is a rough SketchUp I made that it's the very first prototype of the result I was trying to achieve. Since I was experimenting with 3D printing, with 3D design, I have decided to go with 3D printing, so I could easily design some mechanical parts, print them out, evaluate the result, and afterwards keep going on. This is how Braille cell looks like. So as you can see, the cell itself has 6 pins, and it's modular, so we can easily attach or detach cells into the device. And this is how the device looks like as we're using 4 Braille cells. Lovely. And we have to think next, how is it even possible to pop pin? So how is it even possible to translate code into motion, like pins popping out from the device? As I was experimenting with different components, I have decided to stick with a module called solenoid. So this tiny module is used in watering systems and electronic locks. It's relatively cheap, and we can use 6 of them just to build up a single Braille cell. Inside the module has a tiny electromagnet, so we can, and a push-pull mechanism, so we can use the Arduino to just set it up to active position or idle position. Lovely. Okay, so let's bring everything together now. First thing first, we have to try to map Braille to our alphabet. So on the left column, as you can see, we have numbers and characters. In the middle, this is the Braille representation of the associated character, and on the right there is an array with binary values that holds the visual representation of the Braille character. Unfortunately, Braille is not deterministic, so we have to manually map every character and every letter and symbol. So in order to get started, I have created a map that allocates characters with binary data. Zeros are standing for idle state pins, and ones are standing for raised pins. And also, I have created a tiny method that accepts a character and returns the binary representation of the character. Next up, this is a really simple Braille cell class. In the constructor, we are allocating the corresponding pins, so we want to allocate 6 Arduino pins, 1 for each solenoid. And also it has a method called draw that takes a character as an argument, gets up the binary representation, and starts popping or pushing pins. I'm sorry. This class is stateful, so we don't have to reset the entire Braille cell. As the characters change, we will check the state of each pin and decide if we have to pull it or push it. And finally, this is how our main entry looks like. At the very top, we're allocating once more the Johnny 5 module. We will require the cell class. We will create a new instance of the board. And when the board is ready, we will create, we will allocate the cell class. And when the board is ready, we will create a new instance of the cell class that is mapped to pins labeled from 8 to 13. And finally, we're gonna draw the letter A. Okay, I think most of you are quite bored right now, so what's better than giving myself a try with a live demo? Okay, lovely. So just give me a moment to break down this slide a bit. As you can see, on the right panel, there's my live screencast from my webcam here. I have to apologize here because I got pretty scared for getting detained at the airport, so I just brought a single Braille character with me. On the left side, there's a visual representation of combined Braille letters with, it's a typeface called Braille, a brilliant typeface. And my presentation runs inside my browser, so this is just JavaScript and HTML. In the background, I'm running a simple Node.js server that accepts incoming connections, and the server is connected to the Arduino that's connected to the device. So using the input field on the very top, I can write something more inspiring rather than hello world. Okay, holy JS. Okay, when I will press the button, I will split the sentences into single characters and print them out using an interval of 2 seconds. So let's give it a try. Okay. Thank you. Lovely. So apparently our prototype works. So let's bring up some results. As you can see, besides digging through information about embedded development or like soldering parts or electronics, this device is relatively simple to build. It requires just a minor knowledge of electronics, but it's relatively simple. The code itself is like 30 lines of code to run the entire device, so nothing fancy here. Also, the device is expandable, so we can easily attach or detach Braille cells depending on the pins or the board we're using on demand. And finally, we can build up a device with 12 Braille cells for more or less of 40 euros. Okay, but we're not done yet. So as we speak, I'm planning of the second version of the actual device, as this was a rough prototype. So I want to create focus groups with people that are more interested or more experienced into 3D design, get feedback from visually impaired communities, and improve the whole design. Also, solenoids are really good for prototyping, but they are not so energy efficient. Also, the prototype is a bit clunky and a bit heavy, so I think for the second version, we can accelerate development using some modules called microstepper motors. These are precise running motors that are powering CD drivers, or camera lenses. And since these modules, we can salvage these modules and recycle them, so I think we can reduce the size of the device up to 80%, the weight of the device up to 70%, and also reduce the cost. Also, we can try and integrate the prototype using different modules. For instance, we can use buttons for navigation. We can use sensors creating weather stations and so on. Everything that can get connected via Arduino can also get connected to the device. Okay, so for the past few months, as I was working into this prototype, I had lots of talks with some colleagues of mine, some friends of mine, and I was also wondering if this actual prototype could work, if it could actually help people around the globe. I was also thinking of trying to get funding or try to make something more commercial or try to run something like crowdfunding, but I think that actually these thoughts defeat the purpose. So instead, I'm just kindly asking for your help. The entire project is open sourced. In the upcoming months, we'll start an open discussion about the second version. I'm also thinking of building something like a Braille printer or something like a fully compatible 3D printed Braille keyboard. So if you want to get involved into IoT or you want to get involved into embedded development, I think that's a lovely weekend project that you can make. Thank you very much for your time and patience. Do you have time for questions?
Yes, of course, we have a lot of time for questions.
That's a clickbait. You can ask me as many questions as my hosts allow me to.
I find first question.
Thank you for the presentation. I have one question. How much cells can be mapped with Arduino board?
Excuse me?
How much cells could be mapped with Arduino board? Actually, how much cells could you put on the plate?
That's a good question. So different boards have different output pins. Basically, you have to use like 6 pins for each Braille cell. So this board here has like 24 pins, so you can actually attach like three cells. But different boards like the Arduino Mega or the Arduino Leonardo can get up to 36 pins. So you can map like 6 Braille cells. Still, there are techniques called multiplexing, so you can expand your board's output pins. So I think you are limited up to like 20 Braille cells per device, using just different techniques for powering up the whole mechanism. Cheers.
I have another question.
Thank you for your talk. It was amazing. So my question is, what was your inspiration behind this? What are it? In the beginning, I mean.
Yeah. Okay, lovely. So, like a few months ago, a friend of mine is actually a teacher, and she wanted to teach herself Braille. And we found out, she was telling me that there was like a school for teaching you Braille, but it was really hard to get Braille books, or it was really hard to get access to a typewriter. So I have started digging through refreshable Braille displays, and I found out that they were like super expensive. And as a matter of fact, I have built the entire device in order to teach myself Braille, something like exercising, creating quizzes, and using my development computer just to recognize letters. So that was my inspiration. And afterwards, I found out that people all around the globe are suffering from the same issues.
If you have any questions, you can find Theodore in the discussion zone.
Yeah.
Oh, we have another question. Good.
Hi.
On your demo, there was a significant latency in pins working.
Yeah, exactly.
I have 2 questions. Did you measure it?
Yep. So basically, the latency is coming because these solenoids are not correctly attached, because in order to bring the device with me, I had to use something like a breadboard and jabber wire. So I have to use this mechanism here. You can see, right?
Yeah.
So if you want to bring something without latency, you have to actually use soldering, like creating something like a PCB, fully electronic device, and latency it's minimum, something like 2 or 3 milliseconds.
So it's not connected with the emulation and Johnny 5?
No emulation. So Johnny 5 actually transpiles JavaScript code to native C++ code.